Hello friends, welcome to the series of courses on basics of electric vehicle simulations using Ansys. In the second part, we are going to learn about EV motor sizing and motor drive analysis using Ansys software. Let's first start about this course, what this course is going to include and what are the things will be covered in this course. And we will also see what is the approach for this course. So let's understand about what this course is about. So this course is beginner level discussion on electric motor used for vehicle propulsion. So this is a very introductory level discussion for motor technology. What is the approach going to be used for this course? So the approach here is going to be outside in. So first we are going to take the outside approach and then it will be followed by inside of the system. And here we are going to consider the motor as a system. So initially we are going to consider motor as a black box, and then later on we will see what is the design of a motor and how to step by step carry out the design of a motor. The approach also transfers from basic mathematics, here I will call it as a napkin mathematics or very fundamental maths behind the system, and then we will later on switch to the software based design. So if I give you an analogy of the approach, so this is just an image showing that what exactly we are going to learn in this course. So initially we will be having a look at the entire picture as a big picture or bird's eye view, and then we are going to dive into electric motor for electric vehicle application. Let's start about what are the course contents and at the end of the course what you will be learning. So as I explained, it is introductory course on electric vehicle motor technology, and these are the list of the topics which will be covered in this course. So you will be learning about motor power estimation for EV application. Then you will be learning about motor sizing and factors affecting the choice of propulsion motor. So these are the two important points highlighted over here: motor power estimation and motor sizing. So here I am considering these two as separate things. The next topic which we are going to cover in this course is analytical design of permanent magnet synchronous motor using Ansys RM Expert. So permanent magnet synchronous motor is one of the popular motor for electric vehicle application, and we are going to see the design of this type of motor using Ansys software. We will also do the performance analysis of the design motor using Ansys Maxwell software. So Ansys has two different modules. One is called template based design and one is based on electromagnetics. So we'll see both. We'll start with the template based design for Ansys RM Expert, and then we will switch to Ansys Maxwell. So the major fundamentals which we are going to cover in this course are related to motor power estimation and motor sizing. So you might be having a question that what is the difference between motor power estimation and motor sizing? So sometimes it is referred as the same phenomena or same concept, right? But here for this course I would like to make a clear difference between these two. So in some of the cases it may be the same, but here we are not going to consider it same. So what are the important terminologies and how motor power estimation is different from motor sizing? So let's have a look at first motor power estimation. So what do I mean by motor power estimation? So motor power estimation deals with what is the duty of a motor, what motor is required to do, right? What motor is supposed to develop, right? And that is going to also lead to our discussion on estimating the speed and torque on the shaft of the motor. So motor power estimation is basically considering the motor as a black box exercise, and we will assume that all things inside the black box is able to receive input and provide the necessary output. So for a motor, what are the inputs and output? So input is electrical energy and output is mechanical energy. So motor converts electrical power to mechanical power, and we assume when black box approach is taken that input voltage and current quantities are available and output speed and torque are produced. So we are going to understand motor as a black box in motor power estimation. So this is what is the meaning of motor power estimation. If I give you a quick example, let's say you want to actually calculate how much is the power rating of a motor required for the pump which is going to change the level of the water from the ground tank to the top tank. So if you have a 3-story building and you want to have a motor which is going to pump the water from underground tank to overhead tank. So what is the important parameter over here? What is the amount of force required for the water to pump from underground tank to overhead tank? So this is something very much required as a first step for motor power estimation. So water pump motor is just an example. We are going to discuss about an electric vehicle, and we will understand that what kind of duty or what is the role of the motor that it has to play. So the second part is motor sizing. Now what is the meaning of motor sizing and how is it different from motor power estimation? So in this course we are going to treat these two as separate terms. In some cases it may be similar. So what is the meaning of motor sizing? Motor sizing is basically getting the idea of physical size of the motor. What do I mean by physical size of a motor? It means what is the diameter and length of the motor. So usually the motors are of cylindrical structure and they are defined mechanically as dimension and length, right? And fundamentally the motor sizing is nothing but how the required power is actually going to be kept inside the available volume of a motor. So motor sizing is the exercise which deals with determining how much volume will the motor will require, or if for a given volume how much power will the motor be able to produce. So when it comes to calculation of power, we are going to consider the motor as a black box, and when it comes to motor sizing, we are going to dive deep into what is inside the motor, right? But as a very first step, what we need to do is we need to translate this motor power to the motor sizing, right? So that is going to be the first step, where we have a predefined value of the motor power estimated, and for that power indirectly the speed and the torque, and we will be then focusing on how the machine can be designed. So this is what we are going to cover in this course as important terminology. Let us move ahead and learn about the vehicular electrification. So here I am going to talk about the fundamentals of vehicles, and it's going to be somewhat related to history and background of vehicles. So in the first video we are going to learn the fundamentals of electric vehicles as well, and so that it will be easy for you to understand about motors used for electric vehicles. So let's try to understand from the motor perspective what is vehicular electrification. So electric motors are required in most of the IC engine based vehicles as well. So you might be wondering, where do I need a motor for an engine based vehicle? Because the propulsion power is produced by the engine. Why do I need a motor? Right? So you might think of some applications where, for example, in your car, you may require motors for power windows, you may require motor for wiper, and maybe some other applications for HVAC. So heat, ventilating and air conditioning, that may also require some motors. But actually I'm not talking about those motors. I'm talking about the motor which is very, very important. Can you guess which motor I'm talking about? And yes, it is present in all IC engine vehicles. It is the motor called as starter motor. So electric motors are basically very old friend of an engine, right? And even if you consider other engines in other applications, most of the engines will be starting with the help of electric motor, which is called a starter motor. So let me show you an interesting picture of a starter motor for a two-wheeler engine by Honda. So what you are able to see in this image is basically a cut section view of a two-wheeler engine. So here is the silencer at the end of this, and here is where your piston will be. What you are able to see over here is the starter motor, or it is also called as integrated starter generator for a two-wheeler engine. So this is around 100 to 150 cc engine producing up to below 10 kilowatt power. This type of engine requires a motor to start, and this is what you call as auto start, right? So when you have a vehicle where the engine is started using the battery power, and then the same motor will be acting as a generator. So this is what is inside all IC engines, right? So all IC engines are by default started with the help of motor and battery, or we can consider this as electric start. So can we now consider all vehicles as somewhat electric vehicles? Yes, we can call them as partially electric vehicle or electric start vehicles. So if I talk about the next category of more electrified vehicle, right? So that is possible if the size and power rating of the battery and the motor, which are important electrical components, are higher, or if the size and power increases for a battery and motor, it is known as a hybrid electric vehicle, right? So most of the vehicles are by default micro category of hybrid electric vehicle. So even if you consider your purely petrol or diesel vehicle, they are basically micro hybrid electric vehicle. Why? Because they are going to use electric start. So vehicular electrification is very important thing in order to understand what is a pure electric vehicle, and based on what is the size and power of electric system, that will basically define the category of a vehicle which is mild or full or pure electric vehicle. So let us learn about what are these four categories and how these four categories are classified. So these four categories are basically classified on amount of power which is electrical in that particular vehicle. So EV is a special case where it is one of the category of hybrid electric vehicle. So let's understand how EV is a special case of an HEV. Now, in order to understand this, let me show you one important table which is going to categorize the types of hybrid vehicles. So this table shows the functionality of a typical type of hybrid electric vehicle. So for example, a micro hybrid vehicle can help the engine to start, but the regenerative braking and the motor assist is slightly available, and electric drive is not possible. So what is the meaning of regenerative braking, motor assist and electric drive? Let me explain this fundamentals to you. That regenerative braking is basically when the vehicle is decelerating, the kinetic energy stored in the vehicle can be taken back to the vehicle and it can be stored in the battery. That is called a regenerative braking. The motor assist is something which is related to helping the engine to start, and not only to start but helping the engine during the initial speed or low speed operation of the vehicle to achieve higher amount of speed in the first gear. So for example, if we consider the motor assist case, when your vehicle is in the first gear, your motor can not only help to start the engine, but it can also provide power on the shaft such that the vehicle can propel. So another important feature is electric drive. Now, if the electrical system can provide the full power, whatever is the required power for propulsion of the vehicle, if the total amount of power is provided by the electrical system, then it is called an electric drive. So after you have understood all these three important concepts apart from engine start, now you can easily understand the categories of hybrid vehicles. So a micro hybrid vehicle, by default all vehicles are micro hybrid. As I discussed about a start or integrated starter generator for a two-wheeler engine, it is basically micro hybrid. A mild hybrid vehicle is something where the electrical system is going to take more responsibility and provide the regenerative braking and motor assist features. Full hybrid electric vehicle is one such vehicle where electric system can actually contribute independently to the propulsion power. So here there is no need for an engine to actually start. So a full hybrid electric vehicle can run either on engine or on electric system at all. So this is possible in a full hybrid vehicle. Now, does that mean that you have a CNG kit in your petrol vehicle? No, a full hybrid vehicle is basically going to have a complex control strategy where the power sharing is determined by it. So a full hybrid vehicle is something similar to combination of IC engine along with electric, but the overall control is going to be the master control, which will decide which power is required to be used from either of electric or engine. Now, how do we call EVs and HEV? Here is the answer. So for an electric vehicle, the degree of hybridization is 100%. Now, what is the degree of hybridization? In a full hybrid vehicle, if I do not have any engine, right, or if we eliminate the engine and if we take all propulsion power from electrical system only, then it is called a full electric vehicle. So let me give you an equation for a degree of hybridization. So degree of hybridization is defined with this equation. It's electric system power, or we can call it as electric motor power, or it can be a combination of motor and battery as well. So it's the ratio of electric motor power to the total power, where the total power is the combination of IC engine along with the electric motor. So if you consider the degree of hybridization as 100, so this ratio becomes 1. When does this ratio become 1? When you have this IC engine power component as 0. So therefore we can call electric vehicle as a special category of hybrid electric vehicle. So let us move ahead and now try to dive deep into what are the components of an electric vehicle.